I'm going to be honest, this week in artificial intelligence felt different. Not louder, not more dramatic, but more serious, more consequential. Anthropic quietly announced something called Claude Orion, a specialized enterprise LLM tuned for cybersecurity operations and threat analysis. Not a chatbot, not a search engine, not a content generator, a defensive instrument. Simultaneously, we got strong signals that DeepSeek V4, scheduled for mid-February, will pursue agentic reasoning in code execution environments, which has its own security implications, especially when autonomous agents touch production stacks. And finally, a teaser of Falcon H1R, a robotics-class AI model optimized for low-power embedded environments, hinting at the future of autonomous perimeter defense, edge robotics, and distributed sensing. As we enter 2026, it's becoming clear that generative AI is no longer just about consumer assistance or enterprise productivity tools. We are entering the era of AI for security, where language models don't just interpret the world, they defend it. Anthropic announced Claude Orion in what can only be described as an unusually quiet reveal for a defense-adjacent AI product. There was no major keynote, no splashy consumer demo, no hype cycle, just a set of controlled disclosures across enterprise cybersecurity channels, threat intelligence analysts, and SOC architects. According to reporting from Cybersecurity Dive and the Register, Orion is a specialized Claude variant designed to process threat telemetry from SIEM and SOC pipelines, specifically logs, intrusion events, IOCs, exploit signatures, malware traffic patterns, playbook actions, and forensic artifacts. But the key capability isn't just classification or tagging. Those are old problems. Orion is meant to perform narrative forensics. In natural language, explain what happened, how, and why, and summarize likely attacker intent. This matters because defenders are drowning in telemetry. Modern SOCs ingest petabytes of logs from EDR, identity systems, cloud controllers, VPN gateways, and lateral movement sensors. The bottleneck isn't detection, it's interpretation. According to CrowdStrike's Global Threat Report, attacker dwell time is shrinking, while SOC fatigue is rising, largely due to alert volume and incomplete context. Orion's standout feature is automated intrusion storytelling. It reconstructs chain of events, initial access vector, privilege escalation, credential pivoting, lateral movement. This is the kind of reasoning typically done by senior threat analysts, not junior SOC operators. And according to Recorded Future News, Orion was tested in actual post-compromised environments during pilot deployments. The most surprising claim came from VX Underground, which reported early testing involving exploit pattern recognition, especially RCE chains and kernel-level exploit fingerprints. If true, that suggests Orion's training corpus included structured vulnerability datasets, CVE descriptions, exploit write-ups, offensive security research, and red team documentation, content traditionally considered dual use. Anthropic declined to comment directly when asked by The Record, saying only that Orion was designed for defensive applications and aligned with safety commitments. While Claude Orion leans into cybersecurity, DeepSeek V4 is shaping up to be a defining model for what insiders are now calling agentic execution, not just producing code, but running code, inspecting outputs, debugging, and replanning, a full feedback loop. Multiple engineering channels and OSS communities have hinted that V4 will launch in mid-February. This date has been echoed in early developer forum chatter and reposted on Hacker News. But what makes V4 notable isn't the release timing, it's the scope. DeepSeek's internal technical paper for V3 already demonstrated unusually strong performance in long context planning with both code and natural language tasks. The team claimed context windows in the hundreds of thousands of tokens, which was verified by evaluation summaries posted on Archive and benchmarked by LMYS. V4 reportedly pushes that further, targeting multi-agent collaborative workflows, particularly for tasks like system design, refactoring, code audits, CI pipeline adjustments. These are not consumer-grade tasks, they are infrastructure tasks, where output errors are expensive. According to Semi-Analysis and AI Engineering Digest, V4 includes a manager-worker agent model enabling autonomous decomposition of complex coding tasks. If accurate, it would reflect the same direction Meta and OpenAI are reportedly taking, turning LLMs from passive models into active planners. Agentic systems matter in security contexts because autonomous reasoning over execution environments can expose failure modes, dependency vulnerabilities, or insecure coding patterns. And here, feedback from the OSS ecosystem is important. Developers working with DeepSeek V4 reported that it could already explain why code was unsafe and rewrite it without prompting. While DeepSeek targets coding and Anthropic targets SOCs, Falcon H1R targets something different entirely: robotic inference at low power. The teaser was brief, almost cryptic, circulated through robotics research groups and briefly summarized by Robotics 24/7, but the technical claim is compelling: high-performance inference on constrained power budgets. In robotics, constrained power isn't a minor constraint, it's the constraint. If you can run perception, planning, and control at low wattage, you unlock 3 markets simultaneously: autonomous drones, distributed perimeter robotics, and embedded industrial systems. The strategic connection here is perimeter robotics. Edge robots are increasingly used in critical infrastructure monitoring, facility access control, manufacturing, logistics. These systems historically relied on handcrafted control software. H1R implies that generative models are moving into that role. The defense community noticed. Breaking Defense and Janes both covered the shift toward low-power AI autonomy in field robotics, noting that inference latency and thermal constraints have blocked more advanced behaviors. H1R is positioned squarely at that bottleneck. High-end models like GPT-5 and Gemini Ultra run in data centers with megawatt-scale cooling infrastructure. Robotic systems do not. They are constrained by battery life, thermal dissipation, weight, latency, actuator demands. That's it. If you find it insightful, make sure to like the video and subscribe to channel. Thank you for watching. I'll see you in the next one.